All right. Good morning. Thank you all for coming for the keynote. It's my pleasure to introduce Dr. Vita Bortnikov. Here's a very quick introduction to the speaker today. So her talk is going to be titled "The Journey to Multi-Cloud Networking." And Vita is a IBM Fellow for Multi-Cloud Networking and Software-Defined Infrastructure. She leads the networking strategy in IBM Research, building the next generation networking to enable multi-cloud evolution. She's an expert in distributed systems, which is a critical discipline in computer science with applications to cloud computing and beyond. Her passion lies in combining theory and technology to bring about practical innovations for large scale systems. Towards this end, she specializes in high availability, robustness, and scalability applied to enterprise solutions. During her career, she has contributed to a number of strategic products such as WebSphere, Pure App, IBM Cloud, and blockchain. She was also at the foundation of the ISTIO Service Mesh project. She holds her MSc and BSc degrees from the Technion Israel Institute of Technology. So please welcome Dr. Vita.
Thank you. Do you hear me? Okay, assume everything okay and you hear me, guys, because Okay, good. Okay, so thanks for having me, and I'm really sorry I could not come physically to India, but I would be happy to take you through this talk, and I hope we all enjoy it. So, as I was introduced before, my name is Vita Bortnikov, and I'm IBM Fellow from IBM Research. I'm located in Israel, and I was actually in Haifa. And if you want to reach out, this is my connect details, and you are very happy to reach out. So I'm leading the networking strategy and more focusing on multi-cloud networking these days. And I will talk in this talk about the journey to multi-cloud networking. So I will a bit describe it by myself and my career and how I get to work on networking, what I'm doing now. Then I will, before we talk about multi-cloud networking, I will talk about where we are in the cloud evolution, what happens in the cloud, and then we'll connect it to networking and how we believe networking should be, is part of this cloud evolution. I will a bit explain about internet, where we got to this place where we today with the networking journey, describe about application centric networking, and at the end we'll explain how we suggest this solution should be done for multi-cloud networking and introduce some initial ideas and products we have. So I hope it will be a good follow-up. So as was introduced before, I'm expertise in large-scale distributed systems. I work on clustering and high availability of WebSphere VE, actually taking it from a scaling of 100 nodes to scaling of 1,000 nodes on different technologies, including peer-to-peer networking and Paxos and other consensus algorithms. And I work along, a lot in the areas of scalability on the foundation of IBM Cloud and others. I think when starting from WebSphere was what sort of application platform, this was in the inception of the cloud. And we worked a lot on microservices and specifically about how you connect microservices, how you actually, from one big application you create for, finally you get to a distributed state where have a lot of applications, services connected together, and then you need a system that will allow you to discover the services, connect them, manage them, and so on. So this is what brought me through in this cloud journey to microservices, and it was the initial part to Istio service mesh. We created a project called Amalgamate, which was also about connecting microservices, and we together with Google created what is called Istio service mesh. And you will see later on how I believe Istio service mesh is connected to the networking world. And actually, it was a sort of attempt when we came maybe from a different or not only networking perspective, but Istio looked on the networking in a slightly different way than the networking is done in the usual classical world. And I think if we look today forward, we see what we can take from Istio, what was done well, what we can do different. But I think that was my sort of a big part on starting this networking mission. And in the last years, I moved to the networking space, and I'm leading a number of activities in research, leading research, IBM research strategy worldwide on networking, and we focus on number of areas. Mainly this year on multi-cloud networking, we also look on developing novel Linux networking stack together with Red Hat based on eBPF and other Linux new technologies. So this is more or less about me. So if you have after the talk some what wants to connect and discuss and collaborate with us, we will be more than happy. Okay, so let's move to cloud. And before we talk about networking, let's look on the cloud market and the cloud itself. So this is a cloud infrastructure service market, and as we all see, it's growing. And I think if you ask today and you look on the cloud, people will tell you, okay, there are three hyperscalers, which is a mostly cloud market, which is Amazon, Azure, and the third one is Google. But two big are Amazon and Azure. And if you look very high level, you will think, okay, this is where cloud is. Cloud is hyperscalers. They are just growing. But the situation, I think, as we look on this these days, is different. So while the whole market is growing, and Amazon and AWS and Azure are growing, there's also the part of other next 10 providers, as specified on this graph, is also growing. And we do see that enterprises are not moving just to cloud and not to one cloud as its whole. They are having some of the deployments which are mixed. They stay on-prem. They want to run edge, close to where the data is and the processing are edge deployments. They have some regional and sovereign deployments that they don't want to move from one part of the globus to the other part of the globus. And most companies run on more than one cloud. We also see the rise of special vendors that mean that some clouds want to specialize in AIML, some clouds want to specialize on processing of some specific data, want to provide some basic capabilities and not provide as a whole one big cloud. So we do see a way where the clouds become more diverse, more clouds are regional, and more solutions are available than just hyperscalers. And so in this, so I think that is in that world, it's worth mentioning companies like Cloudflare and Akamai, who actually came from CDN world, and they had a very good worldwide spread infrastructure of presence of POPs and so on. So what they are doing these days, they're providing storage and compute capabilities worldwide, and in some sense, they're also becoming a type of cloud providers. So they are also expanding their services. So if we see the cloud market today and where it's going, we believe that this market will be more diverse, more global, and we want more players to be part of this market, and we see it's happening. Just for as an example, let's see a globe and the cloud landscape today, and you see in red the hyperscalers where they are connected. And we will bring two other companies to show you the global presence of a cloud. One is Ridge. Ridge is a company that doing sort of creating from the infrastructure and data centers that are everywhere in the planet. They creating sort of environment that is used in the cloud way. So sort of cloudizing data center. And the third one is Cloudflare, as I mentioned, the CDN provider that becomes more cloud vendor as well. And you can see that those vendors are much wider spread over the globe than hyperscalers. So if I want to use something close to my data center, close to my to where the data is, to sovereign to my region, I would in many cases prefer using including region Cloudflare in my portfolio than just going with hyperscalers. Okay, so let's now look at this in the modern enterprise deployment scene. So I hope I convince you that, and the numbers convince that commonly the enterprises work with more than one hyperscaler, and it happens because of different services they want to consume, different companies they acquired, and everyone was running on separate different clouds. Some services used from AWS, some from Azure, and so on. Or maybe some other decisions that were made regionally or something like that. So, and still the large percentage of deployments that enterprise has run in the local data center or edge or on-prem. So we did look, most of them didn't move to the cloud. So if you look on the enterprise CIO or all operations, it has AWS, Azure, or all other clouds. It wants to use maybe some rich cloud for original clouds, and it also has on-prem and edge deployments. And all this makes their life very hard in all aspects, not only networking. So every cloud has different management API and set of services to use. Everyone has different tools on how I deploy and how I manage security, compliance, and they too, and all other parts. And to work in this world in productive way and make sure we are getting to a point where enterprise can easily say, okay, I have some process that runs here, here, and here, and this is the same process, is very tricky situation. So we do understand that in order for enterprises to adopt to this multi-cloud evolution, we will need to, some evolution needs to happen on how multi-cloud is presented, consumed, and so on. But we are not here to talk about multi-cloud in general. I just wanted to give a background on, how the world looks like from at least my perspective. Now let's talk about networking. Networking provides you even bigger and harder challenge on how you cope with all this situation. So we discussed that I now have different clouds. I have on-prem and edge. More than that, I have connectivity challenge that I want to connect all of this together. Maybe not all at the beginning, but I do want to connect some parts of my applications, and I do want to manage it. I want to manage the policy. I want to manage the understand where everything is running. I want to at least observe my whole thing and see where traffic is working and where is not. So in this world, if you look, and this is maybe how to look from the networking perspective, let's say I'm a global enterprise and I have presence in US and India, and I do consume, in one part I use one SD-WAN provider, and I use some technology to connect all my presence in one country. And in the other country, I choose something else because of different reasons. So now I'm in also networking challenge on both how I connect these two worlds, how I manage them, and I think it's very hard for this new, global enterprise coupled with this diverse situation to go and manage this in a way that is both efficient, secure, and provides you enough level of connectivity and controls that you want to have. And then maybe one part about how enterprise would like to see this all happening. So what we get used to from SDN days, and now evolve, and in the last 10 years away, adopting to one single cloud vendor story. So one single cloud vendor took this SDN or management part of software way you manage your networking to a very powerful tool. So if you go today to one cloud, and I just brought AWS as an example, you can also look on Microsoft, on Azure, IBM Cloud, and others. You have a very powerful fine-grained network management API. So actually, enter cloud, I have VPC abstractions that provide me isolation. I can manage things. I can manage a lot of things in different levels. But let's take network administrator. You have security groups, ACLs. So you have a lot of tooling you want to have to effectively, immediately manage your network infrastructure and isolation. But what's going on from the network functions, and also with the time, in order to provide enough support for network administrators and keep people moving to the cloud, a lot of networking functions that are available in networking space were added to the public, hyperscalers. You can see, from load balancers, gateways, transit gateways. So a lot of functionality you can just get from hyperscalers. So this is one aspect of all software-defined networking and network functions perspective. The other worried about point of presence and private connectivity and global private backbone. What happened to hyperscalers these days? They provided POPs very close to many locations, and as soon as you start and you enter this POP, so you need to get to this point of presence. After this, you have all this rich amount of things you enjoy, and also you have a private backbone. So they have a very performant private backbones, and in some sense they are today providing sort of a new telco capabilities where you have private very efficient transferred globally with hyperscalers. So, and they partner with SD-WAN vendors in order for you to get you from your edge or from your data center to their point of presence. So the whole point I'm trying to make is, as soon as you stay in the borders of one hyperscalers, you're in a great situation where you are fully managed private, very efficient traffic, everything is great. The challenge is that if you connect it to my previous statement that you are usually not in the one hyperscaler, then it's very hard for you to, hyperscalers are not well working one with another. Everyone has incompatible management control, and on-prem and your edge, if you own it and it's not outpost from Amazon, then it's your problem how you manage networking inside in your data center and how you connect your data center to this cloud vendors. So that's saying, okay, this is where we are, and let's discuss what are the tools that were created and where we are now with the networking for multi-cloud, and what is missing and what we believe should happen in this space in the next, years. Let's look now on the market from the SDN perspective. So SDN was born around 2010, and it coupled with the intra-center data management. So this was a virtualization part where it actually provided technologies like L3 router on top of racks, and the companies and this handle the way how you can in software-defined way efficiently provide networking in one data centers. And there was companies like VMware NSX and Cisco ACI, not companies, products that were built for that. The next part in the journey was this SD-WAN part, where okay, I have a networking for my data center, and now I need to connect branches to my data center. So actually, it was also pre-cloud era where you needed to connect, with SD-WAN networking your branches to data center. For this, you need to have encrypted overlays over internet, virtual routers, and all other parts. There are many companies and solutions that were raised in that space, like Cisco Viptela, VMware VeloCloud, Palo Alto, CloudGenix, and others. So in some sense, this is the SD-WAN evolution. And if you look today, it's not enough when we move to multi-cloud and believe that enterprise is global, distributed between clouds and different regional clouds, on-prem and edge, we need to look on the situation differently. We need to look on this like we need solution which we call hybrid multi-cloud SDN, and not only us but also the market look at this way. And we want to get help to enterprises to manage this whole network equip and not and what American deployment they have all over many places. The other piece that I will talk about is about moving from network-centric world where networking is managed in very disjoint part, in very separate way, moving it to application world where we manage more collectively applications and networking. And this is everything we call application-centric networking. So technologies were raised there. Some new startups are running today and addressing part of it. I will talk about them, but I think we see a big opportunity on how we actually allow enterprise to move to the new world. And just to show you how things are connected, if you look today, So everything is distributed, applications, data, users, everything is distributed in dynamic. You want to run same application in different places, and you don't want to do a long process of, network administrator going and checking what exact ports you want to open, how firewall need to be configured, because application developer will want to have very automated way to run his application in one place and then move it to another place. So we need to provide how we connect the things in a world that is growing and becoming more and more complex and more dynamic. And this way we allow business agility. I think to compare this, and I like this graph on right very much, it's about to show you how automated is your compute, whereas how automated is your network. So I think if you ask today, DevOps and operations people, where is automation of compute and where is automation of networking? As I'm not saying that automation on compute is perfect and we are there and everything is great, but it's much more advanced. We have a lot of tooling to do compute automation, where in networking world we are still in a bit orchestration, a build automation, but we have a long journey to make in this part of the puzzle. Let me share with you in that sense about some observations from network architects that we had before, and let's look on applications that was distributed. And I think in some sense you can say, okay, but we are not these days in that space where I really have microservice one running in one cloud, microservice two running in another cloud, and so on and so forth. But I think if you look on even pieces of it, the complexity will be still higher, and we still need to at least start sorting out how we build the systems that can work on that. So we have a growing number of multi-cloud applications that are distributed between different parts of public clouds, branches, and so on. And today, it's not like network administrators, network architects, and application developers are working together. It's application developers and deployments have some needs, and the network ops are reacting to this application's need. And it's not part of application planning. So in some sense, we have two entities, application people and network people working separately, and there is no common way to manage the networking for this deployment. So you can take the whole, and the challenges, there are a lot of products, a lot of diversity, SD-WAN, SAC, SASE products, every cloud has its management, every, SDN on data centers, but it's not common way. And if I come today with this type of deployment, I will not find the tool how I manage it. And the result of it is that we are just not agile enough in how we can do things in this multi-cloud space, because we are sort of locked by networking changes. And another challenge is the security part of the story. It's very hard to guarantee what type of security we provide when we separately manage different network deployments. So maybe a bigger deep dive to a different solutions that were born in that space, to show you, what exists. So if I today come and I want to solve the challenge of managing my network through different deployments, different clouds and on-prem, what is there? One is SD-WAN multi-cloud connectivity. A new companies that were raised in 3-4 years, startups that have a big evaluation and good solutions. Aviatrix, Alkira, Proxima, Volterra. Some of them are solving it in layer 3 networking. Some of them are solving it in application networking. Usually they provide central management orchestration. They sort of not solve the core part of the problem. They provide orchestration solution. They also need to deploy sort of gateway everywhere. They deploy. And this is part of the things. They are all, again, proprietary. They're all, again, disjoint and are not collaborated one with another. So what you will need to do is, let's say you adopt one of them, you will need to deploy it in every place you have your presence. They will help you to connect your deployments between different clouds. They will provide sort of single pane glass of management, but they will not, when if you today want to expand to this to a place where they don't exist, it will be very hard for you to get you will need to solve it by yourself. Another challenge, they don't provide almost anything on-prem deployment, so they are very focused on how to help you to connect different clouds together. They are less focused on how to combine management of on-prem and edge together with the cloud in the same way. So this is one part of the solutions that were specifically raised to the multi-cloud. The other part is SDN companies, as I mentioned, Cloudflare and Akamai. They sort of maybe address it from a different perspective, saying we have a lot of point of presence in many places. Let me present them in. Let the user, I will just help them to connect to Cloudflare, and what from Cloudflare and on, I will provide you a solution. But you are still locked to every one of them. You are locked to their network capabilities, and you are, your evolution is uh, in a space that they will provide solutions. So in some sense, because they are very spread worldwide, it can be a good idea for efficient and secure connectivity worldwide. But on many other things like dependency on management and not addressing your private data center, they are not there. And the next one is actually saying, okay, there was a VPN part where we created this VPN lines between our home and our enterprise. The next generation of VPNs, Tailscale, NetMaker, provide you secure access from any location to any location. And that's a good way to address secure connectivity worldwide, which is independent and agnostic to what you have underneath. Usually the disadvantages of those is they're very initial, they are still not application centric, and the other disadvantage of them is that they don't address the network performance and optimization, so they more address mostly security part of the equation, which is good, but in some cases it does not solve the whole problem, so it's sort of a part of a puzzle but not solving all of it. Okay, so now a bit step aside from some other work that exists in academia and our collaboration with Berkeley, but maybe to look and say, okay, we got there to very, very partitioned, very proprietary networking market where there are a lot of solutions, no real standardization, and why and how we have got there. And maybe a bit of a pity if we look backward, start from internet revolution. So internet was present, we can define the born of the internet in 1983. And the idea was, the breakthrough was that connect computers from different networks together, and TCP/IP actually become a standard protocol for different networks to talk to each other. And every one of us can say, okay, this was a great push forward and standardization. And by the way, network standardization, the internet was not the only one of it, but it was a great part where standardization really helped and create a revolution in what we all see today. Oh, and then there was, but in this 40 years, since this almost 40 years, since this all was 40 years, since this all was created, public networks have not evolved, while the requirements, changed a lot. If you look at where internet was 40 years today and where we are today, so TCP/IP and implementation-wise, we are in the same situation, and all innovation and all evolution, a lot of things that happened in the networking space happened on proprietary things, firewalls and the load balancers and gateways, everything, a lot of things happen, everything in proprietary space, no standardization happened. And the same about, as I go back to my statement about public hyperscalers. So hyperscalers build a lot of network innovation, actually build things that it's very easy globally. You have the full security, but it's all happened in their, sort of doors in a closed way. So if we see today and look on this, and there is a 5 layers of OSI model, but a lot of innovations that happen more in the protocol level happened in the layers 6 and 7, where there is application protocol, HTTP, and all gRPC, and all other things that happen in application layer. But that's a challenge when different applications have different application protocols. While we innovate and bring protocols for these new worldwide applications on the networking space, we are stuck in some way in the same basic TCP/IP and all proprietary stack on top of it. So I think the first guys that may be well formulated and talk about this, you know, TCP, internet evolution, as a Berkeley-led group of researchers with Scott Schenker, sort of, one of the guys who is leading this work about revitalizing the public internet by making it extensible. And if you look back, I think there are many were attempts to make extensible internet, to internet extensible before. And I think we all can be a bit skeptical whether it will succeed these days or not. But I think we should at least remember what they are talking to when we build the next networking solution. And I think the idea they say is, let's create extensible internet. It's a long story. It's a long shot. It's more theoretical stuff today. But we do try to collaborate with them and see how we at least partially can make this happen. And the idea is, okay, part of this internet in the layer 3 was to say, okay, layer 3 will be standardization. It will provide sort of unified network running on different layer 2. But then you are, when you build services on top of layer 3, which is layer 4, you are limited but capabilities that layer 3 has. And this is why the evolution of layer 4 whatever is problematic, because layer 3 is not changing. And in some ways it cannot change because it's sort of common denominator that allows internet. But on the other hand, it must change in order to us to be able to provide globally services that are not provided today and are mostly provided locally. Not locally, but proprietary, but by many vendors, but they are not interoperable, so on and so forth. So the idea they want to say, let's have sort of a internet extensible, and the idea they pitch to say, we need to be backward compatible, so everyone that don't have this extension with the existing layer 3 will be working as usual, but everyone that will start allowing these new services with service load and more, services, more functionality, then we can, things running on top of it can use this new service. And then different ISP vendors can make it available to all the rest. I think the idea, so I think the idea is very interesting. It's really looking on things in a different way and trying to approach things how we can make, how we can extend and make the basics of the internet so we can allow network to grow in more public way and not continue this journey where everyone builds bigger and bigger private networks. Private, I mean owned by some vendor or managed by some vendor. And that's why the whole innovation in networking space is very limited and very I would say, very different from the other world, from the other parameters of the cloud computing. I will get there shortly. We do collaborate with Berkeley. We'll see that some of the ideas we bring are, in this way of thinking about how we create publicly network services that can be shared between users. There are some further works that have to be done in more concrete things that can be done. I think it's a good thought on how this journey can be, making real or partially making real by different collaboration between different companies and academia and telcos. Now maybe going a slightly different route and saying where we are in networking and connect in the network in the cloud. So bringing a bit, cloud evolution of compute and showing you where we are in the networking space and why something very different didn't happen in networking in the cloud, where it maybe, in my view, should have been more innovation in networking when we move to the cloud. So if you look on the compute innovation in the last, 20 years, there was physical machines. Everyone worked with physical machines. Then there was a big virtualization movement. And in some sense, in networking to the SDNs, this was also sort of a virtualization movement, but it was done in a different way. There is a virtualization of network, but maybe it's a bit less power than VMs were before. But in the last years, the big thing that happens in compute world is containers. So it started from Docker, and then Kubernetes came as a compute platform, and actually it didn't bring only compute platform, which is open source and in some way become default standard of how you do today compute with containers on in the cloud. It also it also created cloud native computing foundation with huge amount of projects that came around it, a lot of open source, a lot of ecosystem, and this is what happened and actually make Kubernetes sort of a standard in compute world, not only being it open source, but all the things that were created for running and the CI/CD pipelines and the managing things on top of it and serverless with Knative and a lot of things. So actually, the evolution in compute automation and moving to containers started with Kubernetes and the ecosystem part of it. And why I'm talking to it is about, to bring two theses. One is, okay, it was a great move for compute from Kubernetes and all other parts of it moving and becoming a standard. This would create a real revolution for cloud native compute. What happened in networking? Let's look on it. Why and what happened with networking? So Kubernetes networking was not really any huge innovation. They have pods and services. And what Kubernetes networking was about is how you connect pod and services together. It still is IP-centric networking, not something new that looks on networking in a different way. It provided abstractions called container native interface, the way you implement Kubernetes networking, not something new again. And today, for example, just to bring some information, Cilium is the leading CNI implementation adopted by major hyperscalers, but also leading one. There are others existing like OVN Kubernetes, Calico, Flannel, and others. By the way, when you run on cloud big data centers or clouds, most of the SDN capabilities and most of networking functions are provided by underneath SDN provider, like VPC of Amazon or things like that. And Kubernetes networking just provides you the connection to pod services abstraction of Kubernetes. So it didn't take you to any new, place with the networking part of the problem. Then where's the service mesh? So service mesh, and maybe a bit why we connect service mesh together and why we today look on multi-cloud networking. We, in some sense, both us and Berkeley team and many others look on service mesh, because service mesh, it didn't. By the way, we started with you when we didn't came from the, networking, solving the networking problem per se. It came to say, okay, we have services and applications running in the cloud. We want some services, some capabilities like observability, traffic management, and security to provide for these applications, and we don't want them to be implemented by application developer, so we want them to provide by a platform. And then we created Istio service mesh, and the idea is that you have proxy running near every one of the applications, but I think after that it was sort of used and understood that some of the networking challenges of connecting microservices, controlling policies between microservices, securing them, You can solve with service mesh, and this is first time you solve it in very application-centric way, where actually you define things without talking about IP, networks, and other parts of, classical basic layer 3 networking. You are working on application space, and this provides you a lot of flexibility. Usually, service mesh is used, and it's widely used today for many things. Traffic management is one of them. Observability and security are others. The overhead is you have proxy near every application. The other proxy is that it's very application, layer 7 proxy. And in some sense, and I think Istio is evolving there today. Many of the things that we discuss, you would like to have from your connectivity. You would like to have it application centric, but you don't want to be layer 7. You don't need to understand properties of HTTP protocol. You don't want to go and to have the overhead of layer 7. You want to define things on layer 4, let's say, session based. But Istio was a good way to, today to define connectivity inside one cluster, usually by, working with applications and not working with networks. But this all was, solution, both CNI, Kubernetes networking, and Istio is single cluster solution. And then when I say, okay, maybe we should not look, when we look on multi-cloud, let's look on this layer of application. Let's not look on the layer of networking, on layer 3, IP, ports, and so on. Let's look on the layer of application. What I would like to have is applications running on different environments, VM, on-prem, clusters running in different space, to be sort of connected in an easy way. But today, even if you only focus it on Kubernetes clusters, anyway, you have it only, there are very small amount of multi-cluster networking solutions. They are very limited, and they are usually dependent to inter-cluster management you have. So in the Kubernetes world, where there is huge ecosystem, the idea how you connect different applications, even running in different clusters, were not solved in this world as well. So if we hope that this can be a solution, I think we find out that currently it's not. Just one word about application-centric networking. What happens today is that we would like to have, we would like to position application and then connect them and network to go with application and not to be network configured separately, application configured separately. Another challenge is with, specifically in dynamic environments. We want it to be kettles and not pets. So applications can run anywhere in the cloud, and we want network to be configured as part of applications. So we believe that this is the right approach. We are not there as an industry yet. But I think also if you look on zero trust and things like that, today, if you connect your network from the IP perspective and then you position your application, you need to make sure this atomicity and trust is happening, and really this IP is connected to this application in order to provide, evidence that this is indeed this application talking to this application, and this is connectivity you are allowing. So we do believe that if we look forward on networking, we should solve network in application-centric way. So to summarize, so we believe that networking in multi-cloud should be solved. It has a lot of challenges. It's not just enough to automate and put your gateways everywhere. It will not provide a foundational enough and strong enough solution. You will be always in this journey on creating another layer and another layer of automation, which is very limiting on innovation you can make. There is not existing network application abstractions that we can use. So we are still stuck in this layer 3 ports, security groups, ACLs. Nothing else is still, touch hard and stick to something new. a lot of solutions provide the full stack, proprietary stack, and they are incompatible. And we are in a journey where significant operational overhead is there, and I don't see a quick way to solve it. But if we look how we solve it and what should be, our vision on how this should be solved, and I think I spent 45 minutes maybe to convince them that we need to change the way we think about and start working in a different direction. We need to create open cross-cloud networking fabric to achieve interoperability between different vendors. And maybe we need to have the Kubernetes of the networking world to start be there, to be open and to be created in public, and so that others can, extend it and build on top of it and add more and more functionality, and not be in the way that everyone creates a full solution in its house. We need this new cross-cloud fabric, networking fabric, to be programmable, because we do want to program it in a way that it will be easy to manage and can be, agile enough for how things work today. We want it to be open and extensible, and we want it to be above layer 3. So we don't believe it should be layer 7 in the application protocol because it's too narrow. We do want the all application protocols over there to solve it, but we believe that the right place to solve it is somewhere above layer 3 or in that space. What we suggest in some way, I think the direction is still, we have early experimentation in that front, is sort of creating as a first step forward what we call multi-cloud border gateway that can be run and created in open both as the implementation and as sort of APIs. And this can be run on existing providers. So any existing provider, different ones, can run this MBGs somewhere. And in some sense, if you think about how BGP sort of communicate or agree on IPs, MBGs can exchange information about multi-cloud application and services in order to discuss, I have those services, I have those applications, they can agree on something, and then they can, openly work in this, and get to some sort of, joint work between different vendors in the level of applications and not in the BGP level, and provide us a promise for multi-cloud networking that will be cross-provider adopted by different, parties. So our suggestion is to start and solve it from the cross-vendor, cross-provider problem, and then you don't need to disrupt the inter-data center, inter-cloud vendor, networking. You just start with putting this on the borders. I think there are two possible approaches. We can either go with sort of creating this open SD-WAN layer with MBGs. The other one is also sort of multi-domain, but it's more enterprise application layer. And when I discussed it before, it was more connected to this Kubernetes world and seeing, okay, maybe we should both look on, creating new SD-WAN layers. This is one approach, but it will not be so easy to be adopted because we all understand how it's hard to create a multi-cloud networking, and bring players. The other ways in creating this enterprise application layer networking, where we create a real application abstraction, deploy it, and it seems, okay, I have secure connectivity. Now I talk how I connect applications together. I think we want to experiment with both and see whether we can get to enough of whether we can get with enough of power in the application layer that can be, game changer to solving this complex problem, and on the other hand, to see if MBG can be adopted and we can get it running in different vendors. Maybe a bit of detail. So application layer connectivity, I mean, you want to have applications and connect application running in different environment. Assume you have secure connectivity, and maybe one connectivity was provided by one SD-WAN vendor, another inside the cloud, the other from different vendor. But on top of this connectivity, you want to have policy enforcement, visibility, load balancing. And I think this is sort of saying, okay, we want to try and say, let's see if we can have application networking, connecting application as a layer and make it adopted for different environments. Maybe we start with Kubernetes clusters and then go to application deployed in VMs or any other place. This will require us to think about abstraction. There is no when even start to a good abstraction to be adopted today. Maybe Istio is one of them. It has a lot of gaps. And the implementation one is definitely not the one to go. Current solutions are cluster focused and narrow. As I mentioned, there is Scapper, Submariner. They're available. Cilium has Cilium service mesh. I think there was a trial of everyone that is inside cluster to sort of extend it and go beyond. We say let's look on application connectivity as as a way to define a new novel way for connecting applications as from sort of blank page. The second way is about cross-cloud fabric. And in some sense, if I can tell about it differently, it says, let's provide a cross-cloud provider SD-WAN. So provide gateway technologies that will enable interoperability. What I can tell you is that approach today, going for standards is very slow way to make progress. In addition, what become in the last maybe decade that open source is sort of a way to get standards. Like Kubernetes is not a standard, is like bits on the protocol, but for adoption is sort of a standard. So the idea is let's put things like multi-cloud border gateway. Let's create it in the open. Let's try to follow up with standardization. Let's try to drive community adoption, collaborate with academia, as I talk, Berkeley people, Berkeley team. The idea is that in multi-cloud border gateway, which is very also technologically different from solutions that exist for multi-cloud, we believe that it should be fully distributed control plane. Because if you look on different domains, you cannot be in situation where control is done like in today multi-cloud deployments, multi-cloud networking from one central point, because this is also the management point and the trust point. So you need MBGs to be owned by different entities. And I think if you look on the design core principles, this is one of the things we want to achieve. Meaning in scale, you cannot manage all solutions with one central place main, but mostly not in scale. From the domain perspective, those gateways are located in different domains. So one word before the end about, so this is what I'm talking is our research approach and vision. We have an IBM research. We welcome, comments. We hope, but now a bit about IBM and where IBM is in that space. So IBM is working on a product that is today in beta and going to be GA this quarter, which is called IBM Multi-Cloud Mesh. And I think in some way it tackles the same pain points as I described about, cloud ops engineer, which is more coming from the networking space, and DevOps engineer that is coming from the application space, and how they are, have different agendas, work separately, and the result, how they, the slow progress application modernization journey for the enterprise is there. But a bit talk about multi-cloud mesh is it has a whole idea of application-centric, intent-based, and providing accepting clusters. So in some sense, it follows some of the ideas I mentioned, and we did started to put the gateways that was developed by the team in open. I think still we are more close to solutions. We architecturally going to the right place, but more close to solutions which are proprietary management as other multi-cloud vendors. It has some innovations, many innovations in application space, application centricity. It can connect different layers, so it's work on both layer 3, but also 4 to 7. And it provides you network as a service, meaning the mesh itself, you can manage it in a SaaS way, which is also very important. I think it's a first step implementation-wise. If you want today to manage your multi-cloud deployment, multi-cloud mesh is the first step of bridging between silos and actually manage all your networking both on-prem, which is very important, and on different hyperscaler, and in one central place. It provides you observability and traffic engineering. And I think the most important part is, uniform experience with automation and agility. So if you look on my, in the research and vision perspective we have on the networking multi-cloud, networking for multi-cloud is much more further. While the IBM multi-cloud mesh provides immediate solution, it will take time before we actually get to open source, deploy and work and bring the ideas that I was talking before, that research is working, to something product wise. But I think from the research perspective, we believe that working on open networking fabric is important. So maybe let me summarize the talk. So multi-cloud, from our view, is happening. We are in the beginning of it, and multi-cloud we mean enterprise running on multiple clouds, on-prem, edge. This is what multi-cloud is. Networking multi-cloud is a very hard part of the puzzle. It's a must, and it will be very hard both for multi-cloud to happen without networking, but networking needs a real change in order to adopt and be ready for this multi-cloud space, multi-cloud evolution. We believe that networking needs to be managed together with applications and not separately as it's done today. And I think that is part very important. We miss abstraction here, and we miss collaboration. There are still sort of two camps with networking people and application people. We need them to join forces and see how we can solve this one. Interoperability and standards are game changer. We need to see how we make this happen in the new world after 40 years from internet. And maybe the way we think and we suggest to approach it is to do it through open source. This is a new way of standards, and I think cultural wise, too many things in networking in the many decades happened in closed companies, closed products. We should move to do more things in open. It will not happen in once, but it will and can help us to evolve the network space to much stronger and much better enable of the cloud evolution. And collaboration, I think that is another part of the networking space. So with this, I want to thank you. I hope it was interesting. You are welcome, to reflect your ideas. Any questions or anything you want to ask? Or
Thank you. So we have time for questions. Please just raise your hand 1 second as well. Hi, Vita. Can you hear me?
yeah, I do.
Yeah, this is Varun from Carnegie Mellon. Great talk. So I have a question about like incentives. So this is sort of the same issue that I guess SDN faced in its early days, where you had these behemoths who have a vested incentive and interest in keeping it all vertically integrated and self-contained. In the cloud too, we have these behemoths again, different behemoths maybe, who control large data centers and potentially the edge as well in some instances. So how do you break those vested interests to create a multi-cloud ecosystem, particularly when the interfaces are initially going to be clunky and not, and interoperability is not going to be perfect, at least as we start out?
Yeah, I think that's a great question. I think about incentives, and that's what happened with SDN. The sort of incentives brought this to be one big, large, stack of the things. So we should work on, I think we should work on the incentives. If you look, one of this may be going from application providers and ops companies. That's maybe one incentive. The other is, getting back in some sense power to ISPs and telcos. In some sense, when you took them back, we made all of the network today proprietary big, large, things. We should understand how. One of the ideas we have is start with, telco companies and ISPs that can become or getting back to playing, bigger role in all this. I think it's challenge. But in some sense, if you look on a compute world, I think it started to be solved just from some innovations and community without clear understanding incentives. So maybe we have some promise here. But I agree with you that this is what bringing us always back in that space.
Thank you.
Hi, this is Gary Mundy. I'm Qualcomm. Thank you for the interesting talk. One thing that wasn't really clear to me was you had said that you don't think these problems can effectively be solved at L3, which I tend to agree with. But you also said that interoperability for multi-cloud is not something that should be solved in application space. I wanted to know what you thought about from how endpoints actually actually manage trust in this kind of solution. So I'll give an example. Today, if I'm in a browser and I'm accessing content, and I want to assure that the content comes from an origin server, I create a tunnel to that origin server, and I have a third party, usually a CA, who can actually assure me that the content is authentic. I didn't see really a role for that kind of establishment of trust in the architectural options that you were talking about, but maybe it was there. I was wondering if you could comment on that.
I think it's a very good question. So, we are in the beginning of our journey, and we definitely will need to have, trust between 2 points, as you mentioned. So, in our new, sort of prototypes and solution, we do, sort of have this, currently in the prototype central point of trust. But if at least you separate the trust from other parts, you say, okay, I am assuming in the beginning that I have this trust, trusted servers all of us have to create this trusted connection. But this is the only thing I assume you have in that, distributed architecture. And you try to solve the other problem, then you will probably can evolve the trust part. I think today it's a lot more than a trust when you solve it. But I think we all understand that there are many unsolved questions. It's not like we have questions to everything. I think what we believe is let's start working on it. Nothing we create is full solution end to end now. But we should be doing attempts and moving forward, even assuming some assumptions like centralized certificate authority in order to make to start moving to this direction. I think the challenge, if you don't solve it, what I try to say, it's not only layer 3. I think extended layer 3 is an excellent solution. Whether we can get to something less excellent but still better than all we have today, I believe yes. So let's work, let's experiment and let's see where we land. I hope it answered at least some of it.
Hi, Vita. This is Srihari from Ericsson and a former IBM researcher myself. My question actually follows on from the previous question that you just answered. But probably I have a slightly broader question on that one. Given you have regional cloud service providers and hyperscalers, and we're talking about the open cloud fabric, which is a very cool concept, how do we deal with the the new the attack surface, the cybersecurity threats that come in due to the differential security standards that may be adopted between regional cloud service providers and perhaps global hyperscalers, which have far more depth of automation and cybersecurity standards and so on and so forth? How do we deal with that?
Yeah, it's a very good one, but I think today a lot of cybersecurity is also done on not a lot, all of it, right? It's done on proprietary. There are solutions that are adopted by hyperscalers, by different network providers. We will need to see how we, protect and how we create cybersecurity aspects of what is created as well. But if you go back, it's not means that let's take on standardization on other places where open standards exist and you still can protect things, right? So I don't think that it's not doable. But what you are meaning is like we will need to bring many aspects to this new open networking space, and not only not only to build connectivity and policy and security, that we pitch as as initial step. I think it's a good question. We don't have answers today.
Okay, perhaps the reason I was asking that was, maybe I got interested with that MPG block of yours that you presented, the multi-cloud border gateway, and I was wondering, if there should be something about the security angle also over there, because we looked at the secure transmission, but we don't consider what is being transmitted.
I think let's we can look on it differently. It's very initial concept, and we will need to see how it's do it. We do work about secure connectivity and encrypted connectivity that we believe should be there. We did discuss about cyber security parts, mostly on service discovery parts. So you want to understand how you protect. Once you create secure connectivity with certificate, with the MTLS or something like that, that's I think at least initially can provide you initial level of security. But the way how you securely and adopt to cyber attacks, you protect your service discovery in that world, and application discovery is a big question. So I think we trying to see how it can be solved. But as I mentioned, we are so it's more inspiration. We are now doing initial prototypes, and there will be many gaps that we'll need to solve when we make progress.
Yeah, thanks, Vita. Rajiv Shori from IIT Delhi, formerly IBM Research. Great talk. In fact, the question I think was already asked. That was my question about attack surfaces. But the other question I have, Vita, is that in this multi-cloud environment, any thoughts on the failure mitigation? Because the larger the numbers you have, the clusters you have, we'll have to think of some robust, efficient failure mitigation strategies. Any thoughts on that, or that's something that we're going to just borrow from the previous schemes?
You believe in compute or in network part?
Both, I think.
I think in the compute part, what is currently done, the usual network failure mitigation exists, right? I think what should become there is more observability to your current runtime and what is running where, and some more unified tools on how you manage multi-cloud should happen. But it's there. I believe some of the open sources and some of the ideas how you mitigate this in the cloud space will happen. In the networking space, I think it's much more complex. So today, you will need to take some either to have different network solutions for every space, or to start adopting one of the multi-cloud like the IBM product, but they provide you, central pane of. It's more in the beginning to, understand where the failures are, and less automatically mitigated. I think what you are bringing, all of you, and I agree with that, is that hyperscalers build a strong foundation for many aspects, like from cybersecurity to failure to others, to manage their their deployments across whatever, but across compute, network, storage, everything. And in order to adopt to the multi-cloud, we will need to see, and all this need to be raised now in more multi-cloud space. But the networking itself, in my view, has bigger problems, because because it has two parts. You need to connect two things. If you can live in different deployments, managing your compute and applications separately in different ways, they are not communicate one to another. In network, this is the place where you start, connecting them. And then I think that's a big challenge on solving a networking problem, which is harder in one hand and must be solved in another hand in order to really, make this multi-cloud happen.
All right. Any other questions, please? Okay, so then I think we can close the session. Many thanks to Vita for the talk. Hand from the audience, please. Also, thanks to IBM
Thank
for
you.
sponsoring the conference. Thank you again. Yeah. Bye.
Thank
Right, so
you.
lunch is ground floor near Indian Affairs. So uta madi, as they say. So, okay.